everyone, welcome back to another review session. In today's review session, we're going to be taking a look at functions and decisions. If you want to take a look at any of the code snippets, any examples, or answers to those examples, there's going to be a link to a GitHub repo in the description. So make sure to check that out and do some of the examples, either before we get started here or once I've explained everything and before I show off the answers so that you get some practice before your upcoming midterms or finals in CP104. All right, so first and foremost, let's start off with defining a function. Function is pretty easy to define. We just have to start off using the def keyword. This stands obviously for define, and then we have to give it a name. Function names have to be a continuous string of characters. So let's call our function add. We can't say like add number or something. That's not going to work. It's going to think of it as two different things. So if we want to make a function called add number, we say add number like that. Just make sure it's all one word. And then after that, we have to define our parameters. If we want a function without parameters, we just put two parentheses and then end it off with a colon. So this is going to be a function called add with no parameters, and then the function definition starts here on the next line. But we do want this function to have parameters. So let's call them num1 and num2. All right, so pretty much we've created a function now, and we have to give it a chunk of code to execute. So let's say we want this function to take number 1 and number 2, add them, and then print the result out. So that's pretty simple. There's a few ways we could do it, but let's keep it simple on ourselves. Let's create a new variable called num3, and then it's going to be equal to num1 plus num2, and then we just want to print out num3. So here we can see that this is what this function does. And to call this function, pretty simple. We just have to say, obviously, if we run this right now, we can see nothing is printed out because we haven't called this function yet. It's defined, but it's not called. So to call the function, we have to give the function keyword. This is going to be calling this chunk of code. And let's just say we want to use 5 and 10 as our two numbers. So this should print out 15. And there we go. So it prints out 15. All right. So now we've defined the function, but obviously this is pretty simple to understand what it's doing. But if somebody is new to code or it's a lot more complex function, we definitely want to have a way of showing in plain text in human form what this function does. And that's where docstrings come into play. So docstring essentially is a function definition or a block of text that explains what a function does. So to write a docstring for this, we start off with 3 quotation marks. So why we have to do this is because our docstring is going to be more than one line. And in Python, to define a string with more than one line, we have to use triple parentheses or triple quotation marks, sorry. All right, so we know what this function does. It adds two numbers together and prints the result. So the first line of our docstring should always be what our function does. The next line of our docstring should be how we use the function. As we saw before, all we have to do is put in add and then num1, num2. We don't have to say anything else because this is the only way to use our function. Next, we should put a separator just to separate the use and what happens when we use it. And then we have to define parameters. So parameters. And our parameters are number 1, which we want to be a float because it can be any number. And let's just say it's the first number or something. But we should give it a more accurate description than this for a more complex function. But there's really no need for a function as simple as add. The next is num2, and it's the same thing. Let's just say the second number. And that's pretty much our docstring. We don't have to add anything else because this function doesn't return anything. So yeah, that's pretty much a docstring. Let's take a look at another example really quickly. All right, so here's another function called calculate angles. And essentially what it does, or what we want it to do, is just take 3 sides of a triangle and calculate the angle for each side. Pretty simple. We're not going to be implementing the actual code for this, but let's just like write out a doc string to see how it looks. All right. So we want it to calculate angles of a triangle given the side lengths. And then our use is just going to be calc angles side A, side B, side C. All right. And then let's just split it. Let's not go all the way this time. That's enough. Parameters. We have to say side A, which is a float, is the length of side A, right? Side B, also a float, is the length of side B. And side C, float, is the length of side C. All right, so in the parameters as well, we want to state any restrictions that we aren't going to be handling in our code. So for example, we could have a line of code that doesn't allow the user to enter anything below zero or below for the side lengths. So let's just like not look for that, but just for our ease, let's say side C must be less than side A plus side B. That's just the definition of a triangle, right? So the user shouldn't input any side C that's greater than the other 2 sides combined. All right, so that's our doc string. And yeah, from there, it'll make it a lot easier for us to implement this function because we know what it does, we know what the parameters are, what they should take in, any restrictions we have to be aware of, and whatnot. So those are pretty much doc strings. You're going to be asked to definitely write doc strings for certain functions, probably in your midterm, maybe as well in your final, but this is a crucial skill to have and to be able to explain the functions in simple words, to be able to explain it to anybody who may not want to look at the code, who doesn't have the expertise to look at the code. So doc strings are very important. So let's move on now to another important thing that we're going to be discussing in this review session, which is decisions. So decisions are very interesting because as of right now, we've just been taking in input and providing output regardless of what that input is. Decisions allow us to do different things based on what the input is. So let's say I have statement 1 and it has a Boolean value of true. Statement 2 is equal to true as well. Okay, so there are 3 types of decisions in Python: the if case, the elif case, and the else case. All right, so let's begin with the if case. The if is exactly how it sounds. If the statement that's provided is true, the code below it will execute. So if statement 1, let's say print I love LCS. All right. And now let's do an elif statement. So elif statement 2, print Python is cool. So the if statement has one condition. The condition is if this statement is true, then this code will execute. The elif statement is a little bit different. So if you see here, we can't just have an elif statement with nothing above it. See, it's going to give us an error and it says expected expression. So an elif statement, what it needs is an if statement before it. An elif statement has 2 conditions. Condition 1, the statement provided to it has to be true, and the statement from the if statement beforehand has to be false. Elif stands for else if. So this will only execute if this statement is false and this one is true. So the else case now is if all of the above decisions have been exhausted and none of them have been true, then this is the case that gets executed. So let's take a look at some of these cases and what happens. All right, so these are when both of them are true, we expect only this one to be printed. So let's print that. So I love LCS. So let's make this false now and see what happens. We can see Python is cool. So because this one was false and this one was true, it only did this one. Yeah. And so another one we can try is both of them being false. And so in this case, we should expect it to get to the else case. So yeah, we get there. Another thing that we can look at is, let's say they're both true. And we change this elif to just an if. We can do this, right? So if statement 1 and if statement 2. And we should expect both of these to print out because both of them are true. And there we go. So another thing that we can do when we're working with statements like this, these have to be true or false. So let's say, for example, we want to look at something called equivalency. So to define a variable in Python, we use one equal sign, and to show equivalence, we have to use two. So let's delete these two and say if statement 1 is equal to statement 2, then we print this. Okay? So as we can see here, they're both equal to true. So we can try that out and we get the correct statement. And we can check false. Make sure you define booleans with uppercase. And as you can see, nothing prints out because we don't have an else statement. We can also negate any booleans or any decisions by using the not keyword. So with equivalence, you can do this a different way as well by doing this. This means not equal to. But the not keyword just negates any Boolean expression. So we can do that. And so this is pretty much saying that whatever this is, this not is going to reverse it. So let's check if they're not equal. Boom. And there we go. So that's pretty much all of decisions. You can also, you don't necessarily have to use only Booleans as the items in the decision. Let's say this is statement 1 is 10, statement 2 is 5. And we can say if statement 1 is greater than statement 2, then we print this out. So obviously that's going to print out. So you can use greater than or equal to, but make sure that everything that the result of these two statements has to be a Boolean. So less than or greater than, equal to, a function that returns a Boolean, and whatnot. All right, speaking of functions returning things, that's going to be our next point of contention. All right, so let's take a look now at return statements. So this is the same function that we were looking at previously, where all we do is add two numbers, but a few things have changed. So let's just look at the code itself. So as we can see here, it's the same thing. We're just creating a num3, but instead of printing it out, we're using this return statement. So what this does is now instead of calling the function just normally by saying this, we also have to add a variable to contain the value, because this now is going to return a value out of it. It's not just going to print out a number. And as you can see here, a few things in our doc string have changed. Our use case is different. And we also have our returns now. So yeah, this is pretty much the same thing. Instead of printing it in the function itself, we can do something cool. Because this returns a value, we can say print add 10, 5, and this will return the same thing as if the print statement was in there. So now it's 15, and then let's say num3 is equal to add 10, 5, and then we print out num3. We can see that it's the same behavior. All right. So as you may have noticed, I've switched files to a file called functions, and this is to show off how we import libraries. Because in CP104, you're going to be expected now that you know how to use functions to import them from a separate file. So this is pretty much how you're going to be doing it in CP104 in your labs and your assignments. You're going to have one functions file and then another testing file. So let's say, for example, it's called example. So let's say we have all of our functions in one place and we don't want to have to keep going over and copying them. We can do something interesting with Python. We can import them into our file. So what we have to do is say from functions import add. So what this is saying is from the file functions, and make sure this is within the same directory, or you're going to be calling it a different way. Import the function called add. So now, as we saw before, we can do the same thing. num3 is equal to add 5, 10, and we can print out num3. And let's see what happens. And there we go, 15. So that's how importing works. It's pretty simple. It's going to be the same every single time. You're going to say from functions, import your function name, and that's it. So now let's take a look at some examples. Make sure you check out the link in the description and do the examples beforehand so you can get used to those examples, and then we can take a look at the answers. For our first example, we have to complete the docstring of this following function. And we can see that we have a calc distance function, and it takes in a parameter of speed and time. And what it does is it calculates the distance an object travels. So to use it, we can see that it returns the sum or the product of speed and time. So we can call that distance is equal to calc distance at speed and time. So this is how we're going to use our function. So let's put a little separator here, and now we have to state our parameters. So the parameters are obviously going to be speed, which is a float, and it is speed the object is going. And then we have time, which is also a float, time the object travels. So those are our two parameters. We can say that time must be greater than 0 because we can't have negative time in this case. It doesn't really make sense. So now we have our returns. Let's actually put another separator here so we can easily distinguish between the two. So yeah, our returns now, we just have a distance, and that's also a float, and it's just the distance the object travels. All right, so this is our completed docstring. As you can see, it's pretty straightforward. We laid it out with the uses, then our parameters, and then our returns. So this makes the function easy to understand what it's doing, easy to error check if somebody puts in an incorrect value or something. So here's our second example. We have a function called add fraction, and we need to complete the code for it. So as we can see here, we have 4 parameters: num1, which is the numerator of the first fraction, den1, which is the denominator, and then num2 and den2 for the second fraction. And we need to return num, den, and sum. So num is going to be the numerator of the sum, denominator is the denominator of the sum, and then sum is obviously the numerator of the denominator. So we can start off by making the numerator for this. So we know that when we add a fraction, the numerator is going to be equal to the first numerator multiplied by the second denominator plus the second numerator multiplied by the first denominator. So we can do that pretty simply in Python like this. So as we can see here, our numerator is going to be equal to num1 times den2 plus num2 times den1. And we know that the denominator is always going to be, when we add a fraction, is going to be equal to the first denominator times the second denominator. And then we can just say our sum is going to be equal to numerator over denominator. And we can return this. And so for return statements, we can have multiple returns. So we can say num, den, sum are all being returned by this function. And as you can see here, when we're calling this function, we can say num, den, sum are all equal to add fraction. So we just have to separate them by commas. And that's pretty much this function. So let's move on to the next example. All right, so here's our third example. we have this function called bulk order, and we're going to start using some decisions now. So it calculates and returns the total cost of a bulk order. So here are our conditions. If you order less than 5 items, you have to pay the full price. If you order between 5 and 10 items, you get a 10% discount. And if you order more than 10 items, you get a 20% discount. So we know that we should probably start off with an if statement with our first condition. So to say if we've ordered less than 5 items, we can say if quantity is less than 5, then we should say our return, which is total is equal to quantity times price. So as you can see here, we're not applying any discounts. We're paying the full price, which is going to be quantity times price. That's going to be our total order cost. So after that, we should check if we're between 5 and 10. So obviously, if we are, our next conditions should be an elif, because we can't be simultaneously below 5 and between 5 and 10. So we can say quantity is equal, less than or greater than or equal to 5. And so this is connecting these two statements now. Quantity is less than or equal to 10. And so this is our second condition. So this AND operator is pretty special. It means that both of these statements have to be true for this if statement's code to execute. There's also another connective operator in Python called OR. So this is pretty much just saying if either one is true, then this is true. So let's keep it AND for now. And then since we know that this one should be quantity times price, we also want to apply a 10% discount as laid out in the docstring. So we just say times 0.9. This is going to give us 90% of the original value or a 10% discount. All right. So then our last condition should be, obviously, if we're greater than 10. We can say that total is equal to quantity times price, and this time we want a 20% discount, so 0.8. And then we just return total. So we also want to keep a certain standard. We don't want multiple returns within a function. It's just not very good coding practice. So as you can see here, we could have done this for each of them. So, So we just return that. So this would be the same function. It just doesn't look very good. It's just better to have a variable being assigned and not have just return statements everywhere within your code. So this is just a more correct way of tackling this problem. So let's move on to our last example. Okay, so here's our last example. So we have to write a function called checkNumber, and it's docstring that does the following. So it takes an integer as a parameter, and if the integer is even and greater than or equal to 50, then we return that's a really big even number. If the integer is odd and greater than 50, then we have to return that's a really big odd number. If the integer is even and less than 50, then we return that's a small even number. And if the integer is odd and less than 50, then we return that's a really small odd number. So to get started, let's write out the docstring. It's going to take us a while to type it all out. So this is what our docstring is going to look. I'll just explain it. So obviously this is what our function does, returns a string based on the value of a number. Pretty simple explanation. This is our use case. Our parameters, as stated, are going to be a variable called num that is an integer, and it's the number to check. And then we return a result string, which is the string based on the value of the number. So let's look at our first condition. If the integer is even and greater than or equal to 50, then we have to return that's a really big even number. So if our number is greater than or equal to 50, then we say that result is equal to that's a really big even number. So this is going to be a condition that returns that's a really big even number for any number that's above 50. Obviously, this isn't correct because we still haven't checked if it's even or odd. So to do that, we have to use the modulus operator in Python. So let's say and, this is to connect the two conditions together. We have to say that num, the modulus is the percentage sign. So what this is saying is if num divided by 2, or not if, sorry, but num divided by 2, what is its remainder? So if it's obviously an even number, then we're going to have a remainder of 0. So the modulus operator on num, so num divided by 2 is going to return a remainder. This is pretty much just going to return the remainder equal to 0. So that means that it's an even number. And it's going to be the same for our second condition. We say elif it's greater than or equal to 50 and num modulus 2 is equal, or is either we can say equal to 1, because for division by 2, we know that there's only 2 remainder cases, one that's 0, one that's 1, or we can just say not equal to 0. Let's do it like that, just so we know this new not equal syntax. So then we can say result, that's a really big odd number. And the next two cases are pretty much the exact same, except we just have to replace the num is greater than or equal to 50 with num is less than 50. And then we say our result is equal to, that's a small even or that's a small odd number. And we can just return result. All right, so a little follow-up question. Do we need an else case in the above function? I'll give you guys a second to think about that. But the answer is no. We don't need an else case in this particular function because if you see, our conditions satisfy every single case possible. A number or an integer can only be even or odd. It can't be both. So we don't need an else case for if it's a different result of this remainder. And an integer has to fall within one of two areas, either greater than or equal to 50 or less than 50. So these conditions satisfy every single possibility that our num parameter can take. Like every single possible integer fits into one of these categories. So we don't need to have an else case in this function. So obviously it would be good to have it just in case somebody enters an incorrect number or something, say like result is equal to not a number or something like that. But other than that, for the actual context, if we're assuming everybody is entering integers, this doesn't need an else case. So that pretty much wraps up our review session. I hope all of you enjoyed. As always, leave any questions in the comments down below. I'll be answering them. If you're watching this when it comes out, our midterm review session is going to be on the 19th of October at 7 o'clock. So make sure you come out to that. It's going to be in person. It's going to be free food and stuff. But if you're watching afterwards, that's okay as well. We'll probably post the video of it on YouTube, on Twitch. So just keep an eye out for that and have a good day.